Yeah. So, correct. So this is not something you would be asked on directly on the AP test. Like it never asks you to graph a polar graph for points on an AP question, but knowing what these look like, the basic ones, is really key because they'll ask you things like find the area inside this and outside that. So you need to know like which section you're looking at, and if you orient yourselves wrong, you'll do a lot of work that's right, but starting from the wrong place. So here, what's going on is polar graph paper. You can plot it out. You can Google polar graph paper. It's pretty cool. What do you see? You have concentric circles, right? And then you have like pi over 6, pi over 4, pi over 3, like this, right? So what values do you plug in? They want you to plug in the theta value, and you get out the r value. So when you plug in 0, it's 1 minus this right here. Oh, that's red. Let's go to highlighter here. To this right here. What's sine of 0?
0.
So it's going to be 1. So r equals 1 minus sine theta, like this. So then you have what? Pi over 3. So it's going to be 1 minus. What's sine of pi over 3? Root 3 over 2. And then pi over 2? What's sine of pi over 2? Sine of pi over 2 is what? 1. So it's 1 minus 1. So this is 1. This is going to be 0. Root 3 over 2 is greater than 1. This will be negative, right? So what you have to do is you have to... What?
1 with 0.1 raised.
I'm sorry, which one?
It's like 1 minus root 3 over 2. It's not positive.
Root 3 over 2 is 0.7, right?
Oh, I'm sorry, it is positive. I'm very sorry. It is not negative. I'm sorry, it is not negative, but it is bigger than a half. That's what I think in my head. And then what, 2 pi over 3? So you get 1 minus, what's sine of 2 pi over 3? If you are hesitating on this is the number one thing you can do to help yourself with polar graphing. Seriously. Number one thing you can do is just know your trig values on the unit circle cold. So it asks you to graph each of these. So this first point right here is when theta is 0, sorry, it's r theta. So when r is 1, theta is, sorry, which order does it go in? I always get confused. What goes first? R goes first, right? It's r theta. So in this case, what's the point going to be? 1, 0. So you have the point 1, 0. There it is. And then what does it do when you have pi over 3? It gets a little closer, right? Like root 3 is like what? Root 3 over 2 is what in decimal form? About what? What is it? 0.8. It's going to be like right. It's going to be like right there. Not there. Sorry. Let me go back. Get back here. Come on, you can do it. Undo. So pi over 3, it's going to be like right there if that's 1. And then at pi over 2, what is it? I'll just keep talking to myself. It's fine. It's 0. So what does the first part of this graph look like? It looks like that. If you want to check this, what should you use? Desmos. Thank you. Desmos. Seriously, please use it. Play around with Desmos. Change the coefficients. Bounce things around. Where does it go next, though? That's a really good question. Where does it go next? What's the next point? 2 pi over... What is this? 2 pi over 3? That's this angle measure right here. 2 pi over 3, 1... It's 1 minus root 3 over 2, right? So where does it go? I'll just keep talking to myself. Are these the same?
Yes.
So it's going to go back up here, right? Is there going to be symmetry here? Yeah, there's going to be symmetry. So where it goes back up to here. And then what's the next value? Let's just do pi. What's sine of pi? So it's back to what? 1 minus 0 is 1. So it's back to, unsurprisingly, it's symmetric. It's back to here. So you get that again. Do you get these really cool shapes? Yeah. It's really important that you practice this because it'll give you the orientation to properly integrate and properly differentiate the right things. 1/8, so what does this slice looks like? Let's see here, there, and this is pi over 4, like that. And it's got a r value of what? 1. So in polar, what was it? What was r limited by? What's the biggest value r could be? 1. And what's the smallest value r can be? If you're looking at any point in here, what's the smallest value r can be? 0. Silence I will take to be you understand what's going on and you're ready to move on. So this is your chance. I'm not going to just put things on you, so I'm just telling you what occurs for me. So what about the angle measure here? What's the lowest theta value of all of these points? What's the lowest theta value? 0, right? And what's the highest one? Pi over 4. So in polar, it's kind of nice. You're done. But if you do it in Cartesian, does it get a little more complicated? Yeah, it does. Because what's the key to doing this in Cartesian? Anybody know? Anybody know? Yes, Getchell.
Is it y squared?
What's the key? I don't want the answer.
Using the equation for unit circle.
You will use the equation for unit circle, but what, for how much of it? What's the roof here? If I am doing a Cartesian... Hold on. This is what I'm trying to get at, everybody. If I gave you this right here, if I gave you from here to here and from here to here, let's say that was x equals 2, x equals 3, y equals 5, and y equals 1. What would, in Cartesian, what would this be right here if you wanted to do that in inequalities? What is x between? 2 to 3. And what's y between? 1 to 5, correct?
Yes.
Going over to here, though, why is it a little different? It's a curve for how much of it? All of it?
One side.
So how many inequalities are we going to need? How many regions are we going to have to describe? Close. 2 of them. You have this region right here, and you have this region right here. Because what happens? You have one ceiling there, and then you have a different ceiling right here. You have this one, and you have this one. Do you see what's going on here? So let's talk about the yellow region here. The yellow region, see the yellow region right there? We'll call that A1. There's the yellow region, A1. What is x bounded between in the yellow region? What's the smallest x value? What? Everybody stand up. This is getting a little comical. I'm not sure what's going on today. I'm not asking big, huge questions yet. What's the smallest x value inside the yellow region right here? 0. 0. What's the biggest x value? No, 1 is here. That's 1.
Root 3 over 2.
Nope. Try again.
Oh, right.
Root 2 over 2. What's the coordinate right here, kids? When it's pi over 4, what's that coordinate on the unit circle? Root 2 over 2, comma what? Root 2 over 2. So what's the biggest x value possible in the yellow region?
Root 2 over 2.
Do you agree with that?
Yes.
Are we okay?
Yes.
So it's root 2 over 2, and it has to be that. But you can't take anything up here, right? So what's the bound for y? What's the smallest value y can be? 0. But what's the biggest thing x... But I just gave the answer. What's the biggest thing y can be?
Root 2 over 2.
Nope. Because in totality, yes. But can you have this point right there?
X.
X. What's the slope of this line?
X. 1.
The slope is not x. What's the slope? 1. The slope is 1. So whenever you pick an x value that's between here, the y value has to be less than what?
X.
X.
Yeah.
It has to be less than x. Sit down, everybody.
It's just,
So that right there is the yellow region right there.
you have to split it up into 2 regions.
Or you have to define it as a piecewise function.
I just did y is greater than 0.
Yep.
X is y is less than x, and y squared plus x squared is less than 1.
But it's different. It's a different ceiling depending on what the x values are. Now for the blue area right here, for this part right there, let's do the blue area right here. I don't know why it won't let me.
It's like I graphed the 3 on Desmos in the shade there.
I understand, but let me write this out and then I'll show you what I mean. Okay. So for the x value, what's the next range here? X equals root 2 over 2 all the way to what?
1.
to 1. So it goes all the way up to 1 and root 2 over 2, like this. And what about y? Y still has to be greater than 0, but what's the ceiling now? How do you figure out what the ceiling is now? This is important. Well, what's the equation of a unit circle in Cartesian, everybody? X squared plus y squared is equal to? So what does y equal? The square root of what? 1 minus x squared, correct? So this right here is y equals 1 minus x squared. The y value needs to be less than that. It needs to be below it. So that goes right here, less than this. So when x is between here, y has to be less than x. And when x is between here, y has to be less than 1 minus x squared. You have to break it into 2 because the ceiling changes. Does this make sense? This is way more complicated than using the polar form, correct? Everybody can nod. I'll just talk to myself. I talk to my dogs all the day. It's fine. It is way clearer. That's part of the reason we use polar, because there are certain shapes that are much easier to describe in polar form. There are shapes that are much easier to describe. Right? But do not solve an integral that would represent the answer to this question. What would the area be lying outside 2 plus cosine theta and inside 1 plus cosine theta? Write the integral that you think is it. You're going to try writing this on your own, and then we're going to come together. So write it on your own. You're looking at your quiz yet. So the area formula is going to be from, what was it? It's frozen, thank you. Yep. It's from what to what?
0 to 2.
Nope. Well, hold on. I don't want that. What's the formula going to be?
1/2.
Alpha to beta, yep, 1/2, right? Of what? R squared, then what? D theta, exactly. There's the formula. Awesome. So then, there's the form. What did you do next? Anybody have any observations or tips on how to set this up? I do not want the answer, I want the tip. Yes, Getchell. Say it again? Yes, exactly.
Forget the formula.
It's not a formula, you have it right there. So what should you do?
Big R minus little r.
Don't do that. Make it easier. What can you do to make this easier? Hand motion, what am I doing? Break it up. So what could you do, Sophia, do you kind of see what I'm saying? What should you do first?
First do the integral of the big R.
Yeah, exactly. So what's the big R in this case?
R equals 1 plus cosine.
Exactly. That's the red one, right? And you square that. Now here's the thing I want to ask you. What's the alpha to beta of the red one, Sophia? Did you figure that out? What?
I thought it was
0
0 to 2.
to 2 pi, so you went all the way around?
Yeah.
I think that's great. So in your case, you're doing 0 to 2 pi. I like that. So for the red one, you went all the way around like this. I agree. You can do it that way. Totally fine. So Sophia has put the stake in the ground. We're going to go all the way around. But what do we have to take away? We have to take away the blue circle. So we have to subtract, what's this one squared d theta? What's the inner one? 2 cosine theta. This is the blue one. What are you integrating from and to? What's the alpha and beta?
From 0 to 2.
You could also do 0.
Everybody, this is really important. Just like with word problems in Algebra 2, if you try to do too many things at once, you will get this wrong. I've literally done this problem a couple hundred times with BC Calculus students over the years, and every single time, something goes wrong with the limits of integration on this one right here. You have to be super careful. You have to be super, super careful. Yeah?
The negative pi over 2 to pi over 2.
Okay, now we're just getting creative. You went from what to what?
Negative pi over 2 to pi over 2.
I really like that. That was super smart right there, Franny. So here's the thing. You need to be careful about your limits of integration. Polar integration is not going to be hard because of the integration. Let's talk about this. When you're lost about this, test points. I like what you did there. Let's just play around with it a little bit, okay? If I'm at If I'm on the blue function, everybody, and I'm right here, what's the theta value right there? What's the theta value right there? 0. Y'all can hear me, right? That's 0, correct? Because you're like this. If we go counterclockwise, we're going to here, to here, to here, to here. How far do I have to go? All the way to pi over 2, correct? Do I need to go further than pi over 2? I do not need to go any further, right? But if I want the bottom part of it, what's this angle down here? Negative pi over 2. So, Franny, what you did there was awesome. You did the whole thing right there. Absolutely, you can do it that way. What do you think the most common mistake is? People think of it as going all the way around, right? So what do? They do the big R minus the little r, 0 to 2 pi. Is that correct? No, it's not. It won't work. Another way to do this, first huge thing I need you to be super anxious about. Test your limits of integration, test your limits of integration, test your limits of integration. The second thing, that's my warning. The second thing you need to be careful about, or tip, use symmetry. Is this symmetric?
Yeah.
It doesn't seem like it helps that much, but it can eliminate really, really small errors that'll kill you for the answer point on free response questions. So the other way you could say this, so Sophia, instead of going from 0 to 2 pi on the first one, what could you do? 0 to what? You go from 0 to pi, right? It's the same function, right? And then it's 1/2, but then how many of them do you need? Look what happens to the 1/2. It just goes away, right? What's the other one going to be? 0 to pi over 2. It's 2 times 1/2, 0 to pi over 2 of 2 cosine theta squared d theta. In my opinion, this is a little bit simpler than this. Here's why. I like plugging in 0 more than I like plugging in pi over 2. That's it. So look for symmetry and double, triple, quadruple check your limits of integration. It's the classic thing. The limits of integration on this, every single time someone bites the dust. Because they think of it going all the way around. It's not. Okay, space yourselves out, everybody. It is math competition time. Yeah, Daniel, yes, it would still be minus right there.